Hi, and welcome back to the Low Level Devel channel's Gameboy Emulator development series. In the previous video, we continued the PPU development by adding sprites. In this video, we're going to add the window and then implement the gamepad so we can start actually playing some games. So let's get started. Okay, I'm going to start by running this test ROM to see where we left off before. We can see there's a little piece missing here and the chin down there. That's because of the window. So we need to be able to start implementing the window. So that's what we're going to do this time around. So let's just get into it. I'm going to start by adding a window line variable to our PPU context struct. That's going to be like which actual window line we're on if we're drawing the window. I'm going to initialize it to 0 and the PPU init. Now I'm going to jump into the PPU sm.c. And now we want to increment this window line when we're incrementing y if we're on the window. So in order to do that, let's see, we're going to add a little if check here. So let's see, if the window is visible, which is a function we're going to create. So if the window is visible, and let's do the LCD get context ly. So if that, I'm going to copy that, if that is greater than or equal to the win y, and let's see, ly is less than win y, let's see, plus 144. Let's see. Let's go back to the PPU. That comes from the Y-res, so that's where I just put Y-res in there. So that means that we're going to be on the window. So now we're going to increment the window line in that case. Okay, now let's scroll on down here. Find our VBlank. So in VBlank, we're going to set our window line to 0. Because when the vertical blank, that means we're done drawing this line, so we just want to reset that. Okay, so now going over to the PPU pipeline, let's see, first I'm going to actually add that window visible function that we showed before. And all that's going to do is return whether this LCD when enable flag is set. And let's see, LCD context when x is greater than or equal to 0, and when x is less than or equal to 166, and when y is greater than or equal to 0. So this is essentially just saying, is the window actually on the visible screen? And that's why we're doing these quick checks here. So, and when y is less than y-res. Now let's scroll down here to the pixel FIFO area, past all that. Probably could have split this up into more files as well, but trying to keep it simple. Okay, so this area where we're saying is the background and window enabled, inside here we're going to call a new function that we're creating called, let's see, let's call it pipeline load window. Load window tile. So this is going to pick the tile from the window if the window is enabled. And let's just go ahead and implement it here. So we'll start with window y. It's going to be just a shorthand for this win y. So now I'm going to do an if check to see if the window is actually in the section that we are drawing. So let's do PPU context.pfc fetch x plus 7, is greater than or equal to, and now we need to use that LCD win x variable. Sorry, I probably should have created a temporary variable for that too, but that's all right. So you want to make sure that it's greater than the win x. Okay, and it's less than the get context plus winx plus yres plus 14. So now inside of here, this is where we want to make another check for the win y variable. So we'll use that window y temporary variable we created, and we want to check again this LCD get context. So ly is greater than or equal to the window y, and again ly is less than window y plus xres. Now inside here we're going to figure out what the y for the tile is, for the window tile. So we'll say that is going to be window line divided by 8. So now, again, we're using this PFC BGW fetch data. So previously this would have picked it from the background, but since we're in the window and the window is enabled, then we're going to actually pick it from here instead. So LCDC win map area. Let's see. So we want to get the fetch x plus 7 minus this win x, and we're going to divide that by 8. And I think, what are we missing here? Plus, yeah, we're also going to add in that w tile y times 32. Okay, and it looks like we're missing, yeah, I think I just need to add that parenthesis there. Yep. Okay, so that should draw that fetch tile right there. So now finally we're going to make one more check. If you remember, if this BGW data comes from a certain area, we need to increment that value by 128 so that we just update the tile ID by 128 so it knows to fetch it from the second set of tile data. Let's go ahead and just make a quick build of this. Looks like I messed something up here. This here, just need to copy it into here where I was referencing it. Then I think it'll be okay. Yep. So now if we run this acid test, something's still screwy here. Let's take another look. I think there's something we missed. Okay, yeah, I see the problem. So in our pipeline load window tile, we only want to do this stuff if the window is actually enabled. So we didn't actually do that part of the check. So if not window visible, then return. So then we'll skip this section. So let's make and play it again, and there we go. It looks exactly like it's supposed to according to the documentation and GitHub for this test. So now we have a pretty much fully functioning PPU. I won't say it's bug-free. I know there's definitely going to be some issues with scrolling, which I will address later in other videos, but for now I think this is a good starting point, and we can start actually trying to play some games and implement other features. So the first feature we'll actually implement is the ability to play a game. So in order to do that, let's take a look at the Pandocs and look at Gamepad Input. And this is done via the FF00 register. And there's good documentation about it here. It's all done in this one 8-bit register. There's a couple of bits that'll tell you whether you're selecting action or direction buttons, and then 0 for pressed and 1 for not pressed for right or A, down or start, based on these two selection bits. So let's go ahead and start implementing these. So I'm going to create a new header, call it gamepad.h. Pragma once, and include the common. It's going to be a pretty simple header. I'm going to have our typedef struct, which is going to be our gamepad state. So what are we going to have? We're going to have the state of our buttons. So your state of our start, select A, B, up, down, let's see, left, right. Okay, and now we'll have a void gamepad init, which is going to actually initialize this stuff. Gamepad init and a gamepad button cell. And that'll return a bool. That's going to tell us if a button is selected. And let's see, gamepad dir cell. Sorry, not if a button is selected. That's going to tell us whether we're selecting buttons or we're selecting directions. So now we're going to set the selection. And gamepad state. This is going to get our gamepad state so we can use it elsewhere, like in our UI code. And then gamepad get output, which is essentially going to be the value that we're going to be reading from the bus. So let's implement that in a gamepad.c. First we're going to include our gamepad.h, and what else do we need? String.h for, yeah, so let's see. Now we'll do our actual gamepad context. So button cell, dir cell, that's going to come from these two bits here. Again, these let us know whether we're selecting buttons or whether we're selecting direction. And then we'll have our gamepad state in there, which we'll call our controller. And create our context object. Initialize it all to 0. And now we can start implementing some of these. So starting with gamepad button cell, it's just simply going to return ctx.buttonCell. Dir cell is going to return ctx.dir cell. And now gamepad set cell u8 value. This is from the bus right. And this is where we are going to actually grab the value of this button cell. That specific bit is set. Then we know it's a button cell, and if this bit is set, we know it's a dir cell. And that comes from, again, these two. So bit 5 and bit 4. Okay. So now our state gamepad get state. Of course, going to simply just return the address of ctx.controller. And moving down, now we're going to implement our gamepad get output. So that is going to start with an output value of 0xcf. So it's essentially setting all the bottom bits of this output, because the selected is actually 0. So if a button is down, we want to set it to 0. So we're starting out with everything set, and then we'll go back and unset based on whether it's selected or whether it's pressed. So now we're going to say if the Gamepad button cell flag is set, if not set, sorry. This is where it gets a little confusing, because that means it's active when it's not set. So that's why I'm doing the not there. So now I'm just going to do some ifs here. If let's see, start is pressed by the user, then I'm going to turn off bit 3. So output and equals, okay, and then that's the start button. So that's bit 3, and remember 0 means it's pressed. So that's why I'm turning it off here. Turning off bit 3 in the output if start is pressed by the user. I can just copy this and do all these. Let's do start, select, A, B, and that's 2, 0, and 1. Now looking at this code again while I'm typing, those should probably just be ifs, not else ifs. That way, you know, you can hold down the A and B at the same time. So you might want to make that change on your own. And now we're doing the same thing if the direction cell is unset. So we'll do it for left. Let's see, right, up, and down. And then we just grab these values again from that documentation, 0, 2, and 3. So that's going to give us the actual output that we're going to return. And that'll let the game know which of our buttons are down. I think that's all there is to the gamepad. So let's wire it up to the bus, and if you remember, it's an I/O device. So up here we can just add another section, if address equals 0xFF00, because that's the register for joypad. Then we're going to return, oh, let's include it, gamepad.h. So then we're going to return Gamepad Get output. And then for writing, if the address is 0xFF00, in this case we're going to do gamepad set cell and pass in the value and return. And that's all there is to the I/O writing up. So let's make that and make sure it builds. Okay, builds okay, and we can still run it. That test doesn't actually have any joypad input, so we need to use an actual ROM. I'm going to use, let's say, Dr. Mario. And right now it's not doing anything. And you know why? Because we didn't actually wire it up to the button presses. So let's do that. So down here in the UI.c is where we are going to put this code. So in our UI handle events, actually I don't think we need these. I thought I was going to need them for some reason, but I guess I don't. So let's just add a couple of little things here to check for certain keys. So we're going to say e.type is SDL key down. So if there's a key down, we're going to call UI on key true. The actual key symbol. And let's see, likewise for key up, passed the same thing but false for the first. And now UI on key is some function that we're going to need to create. So let's do it up here. Let's see, the down flag and then the actual key code. So in here we can switch that key code and let's say to do handle up down. We might want to do some different things based on up down, so like have a UI on key up and a UI on key down, but for now I'm gonna just switch case in here. So SDLKZ, that means that the Z key was pressed. Actually, let me get rid of that. I'm just gonna do it all inside here. SDLKZ. Z, I guess we'll make that our A button. Let me include the gamepad up here. So here we want to say Gamepad Get State. B, we'll make it the B key. B equals down. So if the key is down, then B is down. If the key is up, then B is up. Okay. And then X for A. So then we'll do return will be start. And let's say tab will be select. I could probably choose better keys here, but for now these will work for me. And then we'll use the up arrows for the actual arrow keys as well. So up, down, down equals down. Don't confuse those. Left and right. So now this is going to complete the wiring up of the keys with the gamepad, and now let's build it again and let's run Dr. Mario. Look, I can switch between player 1 and player 2. Actually press and start. Now I can move these things with the arrow keys and actually play this game. I'm not really actually that good at this video game, or many video games to be honest, but as you can probably tell. But let's see if I do that. Oh, there you go. I'm actually not a big fan of this game in the first place either. Oh, almost made it. So you can see the arrow keys are working pretty well. And let's see if I bring up another game. Let's try Tetris. Okay, this one you gotta wait a few seconds for this thing. Yep, and let me move things around. And actually I'm pretty bad at Tetris too. Actually my son and my wife are both a lot better at Tetris than I am. But I'll go ahead and try to play it, just so you can see the actual the PPU is working pretty well, the gamepad is working well. Bam, there goes the line. And let's put that over there, and there's another one. And I'm already messing the game up. So let's see. Let's try Super Mario Land. That one's stopping, so something wrong with that one. I'll probably fix that in a later video. Actually, I think that's probably a good stopping point for us anyway. In the next video, I'm actually going to implement the MBC1, which is how we read larger carts so we can run games like Metroid or Zelda, games that require more than just ROM data, and some of them will actually have RAM and all that. So I think that's a good stopping point. Again, I hope you enjoyed this video and learned something. If you did, like, comment, subscribe, join our Discord channel, and thanks for watching.